Imagine a lake as wide as a nation, buried beneath 4 kilometers of solid ice, sealed in absolute darkness for longer than our species has existed. It is real. Scientists confirmed its existence using radar pulses fired through kilometers of glacial ice, and they named it Lake Vostok. Its surface area matches the entire country of Belgium, and the water within it has not touched open air in 15 million years. What could possibly survive down there in that absolute dark, in that silence that has lasted longer than the Himalayas have existed? The answer rewrote everything we thought we knew about the boundaries of life on this planet. To understand Lake Vostok, you must first understand that Antarctica is not simply ice floating on ocean, it is a true continent buried beneath a frozen shell. The ice sheet blanketing Antarctica averages 2.5 kilometers thick, pressing down on the bedrock beneath with the weight of 17,000 skyscrapers stacked upon each other. That immense pressure generates heat, and that heat melts the base of the ice sheet, creating pockets of liquid water far beneath the surface, held liquid not by warmth, but by sheer weight. Scientists call these subglacial lakes, and to date, more than 400 of them have been mapped scattered across the Antarctic continent. But among all of them, Lake Vostok stands alone larger than every other subglacial lake on Earth combined. It stretches roughly 250 kilometers from north to south, spans 50 kilometers across, and plunges to depths of 400 meters at its deepest point. The volume of water held within it, roughly 5,800 cubic kilometers, equals 3 times the fresh water contained in the entire Lake Erie. And all of that water has been sealed from the outside world since before the first mammoths walked the earth, since before the Sahara was a desert. The story of Vostok did not begin in Antarctica, it began in Moscow during the Cold War, when 2 superpowers raced to plant their flags at the ends of the earth. In 1957, the Soviet Union built Vostok Station directly above something vast and ancient that no one yet suspected was there. The station was built at the coldest surface point ever recorded on Earth, where temperatures have plunged to minus 89 degrees Celsius, cold enough to freeze carbon dioxide out of the atmosphere. Through the Cold War decades, Soviet scientists drilled core samples into the ice, not knowing that every meter they descended brought them closer to something unimaginable. Those ice cores held Earth's climate history, layer by layer, a book written in snow and sealed by centuries of cold, each annual band a page no human had ever read. The Vostok ice core became the longest and most significant ever extracted, reaching 3,788 meters into the ice, carrying climate data spanning 420,000 years. Then, in the early 1990s, something strange began appearing in the deepest cores, something that should not have been there at all. At around 3,500 meters, the ice changed abruptly. It became clearer, its crystals vastly larger, its structure unlike anything extracted from above. This was not compressed snowfall. This was ice, formed by refreezing from liquid water, below which could mean only one thing. There was liquid water beneath the drill. Russian scientist Andrei Kapitsa and his British colleagues analyzed radar survey data from overflights and confirmed what seemed impossible: a liquid lake, sealed beneath the ice for millions of years. Radar maps revealed a perfectly flat, mirror-smooth reflective surface directly beneath the ice base, and only one substance in nature creates that kind of perfect reflection: liquid water. Lake Vostok was formally announced to the world in 1996, and science immediately asked the question that still has no complete answer today. The question was simple and staggering in equal measure. If there is liquid water, could there be life? To understand why that question mattered so profoundly, you need to know one foundational principle of biology. Life, as we understand it, requires liquid water. This is not just theory. Scientists have found life in places once considered absolutely impossible. In boiling acid springs, inside the cores of nuclear reactors, kilometers deep in solid granite. These organisms, extremophiles, forced scientists to redraw every map of where life is possible on this planet and, by extension, in this universe. In the 1980s, thriving communities of organisms were discovered around deep-sea hydrothermal vents in the Pacific, living without a single photon of sunlight, powered entirely by chemical energy. These organisms use chemosynthesis rather than photosynthesis, harvesting energy from chemical reactions between rock minerals and water, with no connection to the sun whatsoever. That discovery changed everything, because it meant sunlight was not an absolute prerequisite for life, only a convenient one for life on the surface. And if life could flourish in total ocean darkness, fed by geothermal energy alone, then why not in a lake sealed beneath 4 kilometers of Antarctic ice? Lake Vostok's water sits at roughly -3 degrees Celsius, but it does not freeze, because the pressure of 4 kilometers of ice above suppresses the freezing point dramatically. The pressure within the lake equals roughly 500 atmospheres, equivalent to 500 adult humans standing on every square centimeter of its surface. Those conditions would kill most known organisms instantly, but for pressure-loving extremophiles, known as piezophiles, high pressure is not a barrier. It is home. The lake also holds extraordinarily high concentrations of dissolved oxygen, roughly 50 times higher than in ordinary surface water, sustained by millennia of ice compression above. Such oxygen levels would poison many organisms, but they could also power an entirely different kind of metabolic chemistry, one adapted over millions of years to thrive in that exact condition. In the early 2000s, scientists analyzed ice samples from the deepest refrozen sections of the Vostok drill core, the material closest to the lake water itself. These samples formed when lake water touched the base of the ice sheet and refroze, carrying upward whatever was suspended in the water at that precise moment. And within those frozen samples, scientists began finding something no one expected: traces of microbial DNA. Initial results suggested dozens of distinct microbial types within the lake, but the scientific community was cautious, because contamination from the drilling process was a genuine and serious risk. The drills required antifreeze lubricant fluid to prevent borehole collapse, and that fluid could carry surface microbes down into the depths, contaminating every sample. This posed one of the greatest challenges in field science history. How do you sample a completely pristine environment without destroying the very purity you are trying to study? It was not until 2012 that the Russian team achieved what they had been working toward for more than 20 years. After decades of drilling, after countless seasons of isolation, where cold, so extreme machinery failed, the drill finally broke through into the lake water below. It was a historic moment, the first contact between the surface world and the waters of Lake Vostok in 15 million years. Due to the enormous pressure differential, lake water instantly surged up the borehole, then refroze meters above the contact point, sealing itself shut within hours. Scientists collected that refrozen water as it solidified within the borehole and brought it to the surface for analysis. The initial analysis, published in 2013, stopped many scientists. Cold, the sample contained DNA from at least 36 microbial types. But controversy erupted immediately. Many of those sequences could have originated from the drilling lubricant fluids, not from the lake itself. Several of the sequences, however, matched nothing in the global DNA database and could not be explained by drilling fluid contamination under any reasonable interpretation. One of those sequences showed faint similarity to bacteria in the hydrogenophaga group organisms known to generate energy from hydrogen without requiring any oxygen at all. If confirmed, it would mean organisms living in the lake sustain themselves entirely through rock-water chemical reactions, a parallel ecosystem to the deep Pacific vents, hidden beneath Antarctic ice. The scientific community continued debating the Russian team's findings because to prove life in an environment untouched for 15 million years, you need evidence beyond reasonable doubt. In 2015, an independent American research group reanalyzed the Vostok sample data using far more rigorous next-generation sequencing methods. Their findings were less dramatic but more persuasive evidence of at least 3,500 genetic sequences potentially of lake origin belonging to bacteria and archaea. Archaea, one of the three great domains of life on Earth, are typically the first organisms found in extreme environments, ancient lineages that predate the age of complex cells by billions of years. The presence of archaea in the lake would make perfect sense. They are renowned for surviving in low oxygen, high pressure, extreme temperature, and high salinity environments that kill virtually all other life. But what truly excited scientists was not the familiar microbes, it was those sequences that matched nothing in any known database, potentially representing entirely new branches of life. In biology, when you find a DNA sequence matching nothing in any database, three explanations exist: contamination, technical error, or an entirely undescribed species, new to science. With Lake Vostok, that third possibility is not fantasy, it is scientifically reasonable, even expected. Consider this: if a microbial population has been isolated for 15 million years, through billions of generations of evolution in utterly unique conditions, what would they have become? They would bear little resemblance to their ancestors. 15 million years is enough time to transform a species into an entirely new genus or even a new family of life. For perspective, 15 million years ago, our own ancestors were not yet upright. We did not yet exist in any form remotely resembling modern humans. And yet, during all of that time, life in Lake Vostok may have been evolving continuously uninterrupted, in perfect darkness and silence, knowing nothing of dinosaurs or ice ages, or us. What would sustain organisms in that lake? The most likely answer involves a process called chemolithoautotrophy life, powered entirely by inorganic chemistry. The lake bed is formed of granite and volcanic rock, and these react slowly with water, releasing hydrogen and dissolved minerals that serve as raw fuel for chemosynthetic life. There may be a complete ecosystem down there: tiny, slow, ancient producers fixing chemical energy, consumers feeding upon them, perhaps even something larger, perched quietly at the top. The word ecosystem sounds grand. In this case, it may mean a few million bacteria per square centimeter of lake bed, metabolizing so slowly their entire life cycle spans years or even centuries. But here is the wonder: those slow organisms, if real, have survived and evolved and adapted in an environment utterly isolated from every extinction event, every ice age, every meteor that ever struck this planet's surface. When the asteroid that killed the dinosaurs struck 66 million years ago, Lake Vostok did not yet exist. But the distant ancestors of whatever lives there now survived every catastrophe since, sealed below, unknowing. This makes Lake Vostok not merely a scientific site, it is a philosophical question. If life can endure in complete isolation for 15 million years on Earth, what does that tell us about life elsewhere in the universe? Europa, Jupiter's moon, holds a liquid ocean beneath tens of kilometers of ice, warmed not by the sun, but by Jupiter's tidal forces. Its structure mirrors Lake Vostok with unsettling precision. If life can exist beneath Antarctic ice, in darkness and crushing pressure without sunlight, the barrier to life existing on Europa collapses entirely. The same logic applies to Enceladus, Saturn's moon, where plumes of water vapor erupting from southern pole cracks carry organic compounds and hydrogen molecules, potential signatures of active chemosynthesis below. Scientists at NASA and the European Space Agency are watching what happens at Vostok very closely, because what is learned here will define how we search for life elsewhere in the solar system. But let us return to the lake itself. Because beyond the question of life, something equally remarkable is happening within Lake Vostok from a purely physical standpoint. The water in the lake is not still. Despite complete isolation, Lake Vostok has its own circulation system driven by temperature differences between the geothermally warmed base and the ice-chilled upper layer. Measurements suggest water from the lake bed takes roughly 50,000 years to complete a single circulation cycle to the surface, and back 50,000 years for one turn of the wheel. To grasp that the last time that molecule of water was near the ice ceiling, humans were living in caves and agriculture had not yet been invented. This means any organisms in the lake must subsist on a closed chemical loop, recycling only what has been in that system for 15 million years, with no fresh nutrients arriving from outside. This is the closest thing to a perfectly closed system anywhere on Earth, a natural experiment in self-sufficiency running across geological time, with no external inputs and no waste outlet. The lake holds one more physical secret: it is not uniform. Lake Vostok is divided into at least two distinct basins by a submerged ridge running across its middle, creating two potentially different chemical environments. The northern basin is shallower, with apparently different chemistry to the deeper southern basin, potentially meaning two distinct microbial communities have been evolving in parallel within the same lake. If confirmed, Lake Vostok is not one evolutionary experiment, but two running simultaneously, separated by an underwater mountain range, isolated from each other for millions of years, as surely as if they were on different planets. This is the kind of complexity no one anticipated when the lake was first confirmed in the 1990s. The deeper we look, the more intricate and extraordinary Vostok becomes. But here is the thing that makes it impossible to stop thinking. If there is life in Lake Vostok, it has no knowledge whatsoever that we exist. It has never experienced sunlight. It has never known sky. It has never felt the turn of seasons. For 15 million years, its entire universe has been darkness, pressure, and absolute silence. And through all of that time, it has done the one thing life always does: endure, adapt, and continue. This raises a larger question about the nature of life itself. We tend to define life through complexity, through consciousness, through experience and sensation. But life in Lake Vostok, if it exists, has no consciousness, no experience, no purpose. It simply persists, and in persisting, it challenges every definition of life we have ever tried to construct. Life needs no observer to confirm it. It needs no name. It simply exists in darkness, beneath 4 kilometers of ice, for 15 million years, whether we know it or not. Clean drilling efforts to extract water directly from the lake continue. The Russian team reached the lake surface in 2012 and is planning cleaner, more controlled sampling missions in the years ahead. An international consortium is developing ultraviolet sterilized cryobots, probes that melt through the ice and sample lake water without carrying a single surface microbe downward. That same technology is being designed for deployment to Europa aboard future NASA spacecraft, meaning what we learn at Vostok is a rehearsal for what we will one day attempt in the outer solar system. In 2012, a separate American team called Wizard drilled into Lake Whillans in West Antarctica using only ultra-pure hot water, no chemical lubricants, zero contamination risk. And they found life. Clearly, unambiguously, definitively thousands of microbial species living and actively metabolizing in a lake far smaller than Vostok, but sampled without any contamination. The Whillans finding was the first truly unambiguous proof of life beneath Antarctic ice, and it made the question of Lake Vostok more urgent than ever. If life exists in Whillans smaller, younger, shallower, the probability of life in Vostok, deeper and vastly more ancient, increases in a way that is difficult to dismiss. 300 million years ago, before Antarctica was glaciated, this region was warm with rivers and forests. Vostok may be the remnant of a surface lake from that age, sealed beneath ice as the continent froze. If so, there may be sediment layers at the lakebed containing fossils from that ancient warmer world organisms that were frozen and preserved as the ice sheet grew above them over millions of years. Those fossils, if found, would be a biological and climate record of Antarctica when it was a warm continent, a window into a world that no longer exists anywhere on the surface of the Earth. There is one question that has no easy answer. Should we drill into the lake at all? Every time we penetrate the lake, however, carefully, we risk introducing something that has never been there, permanently altering the pristine environment we are trying to study. This is one of fieldwork's most painful paradoxes. To study something completely untouched, you must touch it. And the moment you do, it is no longer untouched. Some scientists argue we should leave Lake Vostok entirely untouched, that its value as an undisturbed environment surpasses any discovery we could make, that some things should remain unknown. Others argue that understanding has its own irreplaceable value, that if life is there, the universe deserves to know, and we are the only ones capable of asking. And so, Lake Vostok remains 4 kilometers beneath us, keeping its secrets with a patience that only 15 million years of isolation could produce. We do not yet know with certainty whether life exists within it. The true answer may require decades more of painstaking, careful work before it arrives. But the question of Lake Vostok is not really about the lake. It is about what we are truly asking when we look into darkness and whisper, "Is anyone there?" It is the oldest question humanity has ever asked this time not toward the sky, but downward, into the deep interior of the planet we call home. And if the answer is eventually yes, if we do find life in Lake Vostok, it will rank among the most important discoveries in the history of our species. Not because it would answer the question of extraterrestrial life, but because it would prove that life is not a rare accident, but something the universe does repeatedly wherever conditions allow. And somewhere, beneath 4 kilometers of ice, a creature smaller than the period ending this sentence is breathing, enduring, knowing nothing of us, just as it has known nothing for 15 million years.